This is the metabolite identification page for the nmRanalysis app. In the graph to the right, users will see that the filters from the previous page are carried over if they had specified them. In the top left corner of the page, users can choose to use our Detect Peaks tool. This step is optional, but it's meant to automatically highlight regions of potential interest. For peak detection, we use the Continuous Wavelet Transform method, or CWT method, as implemented by the SpeakR package. Users can choose to adjust several parameters. Spectral segment length is the width of the sliding window used by the CWT method when searching for peaks. This width should be no smaller than the largest width peak in your observed spectra. CWT scale factor range defines the minimum and maximum scale parameter values to be used in the CWT method for peak detection. The CWT scale factor is proportional to the detectable peak width. The maximum value should be no larger than 64. CWT scale factor step size is an increment by which the algorithm iterates through the range of scale factors. Signal to noise threshold sets a threshold to the ratio of the estimated peak signal strength to the local noise level of the peak as estimated by the CWT method. And finally, intensity threshold sets a minimum intensity threshold for detected peaks and may be visualized on the spectra by toggling Visualize to On. Once the parameters are selected, users can click Detect Peaks to start processing. This process could take a few minutes. After peak detection, users will see annotations appear on the graph. These annotations can be grouped to one another using the Peak Grouping Threshold field, making for fewer annotations. Users will select metabolites from a list and select Compute. This will produce a table that displays a calculated probability that a given metabolite is in the data. The table also includes a model column that shows what model or algorithm generated the provided probability. PRAUC and ROC-AUC are model performance metrics, with values closer to 1 being better. This table can be downloaded as a CSV if desired. In the Feature Querying tab, users can choose a custom location based on ppm. Or, if the user has performed peak detection, they can select from the signals annotated by the peak detection algorithm. The program will then generate a table that shows all of the metabolites with known signals within the search tolerance of the selected ppm value. The specific location of these known signals and their multiplicities are provided, along with the known experimental conditions that the signals were measured. A column indicating whether predicted probabilities are available for a given metabolite is provided, and these predicted probabilities may be displayed by selecting Yes from the Compute Metabolite Probabilities question in the top right of the field. If the user wants to add a metabolite to their analysis, they can click on the row and then click Add Metabolite to Identification. Clicking on an entry also displays the location of all the other known signals associated with the selected metabolite, and the proportion of samples with detected peaks within the search tolerance of each of those signals. Finally, selecting a row will also display annotations on the plot that mark where all the known signals for that metabolite have been observed. On the Identified Metabolites tab, users can see a list of metabolites they have added to their selection, and remove them if desired. After this page, users will move on to the Reference Data Editing page.